Hello again. Today we are going to talk about chapter, this will be very exciting, I'm sure, 2.1, linear and quadratic functions. Now, I'm assuming everybody knows about linear functions and drawing lines and slope-intercept form, but you know what? We're going to go over it anyways, because I bet a lot of you forgot about that stuff. So let me move this a little closer. That's a little better. Okay, so linear functions. Very important, useful in a lot of things. Linear functions, y equals mx plus b. This is the slope-intercept form because it gives you the slope here and it gives you the y-intercept. There's the point slope form, there's the general equation of the form, blah, blah, blah. I use this so that I make every problem look the same, okay? I'm not going to ask you solve this equation and then put it into the general form of the equation of the line, because I don't really care about the different forms of a line. This is the one that's most useful, and I make every problem look like a slope-intercept form problem so that every problem looks the same. And that is critical in your career in math, is as much as you can make the problems all look the same, then all you need to remember is one pattern. And so here we're just going to focus on one pattern. Now, let's go through and do some other definitions. The slope is from here to here, it's how much the coordinate rises when it goes horizontally from this x coordinate to that x coordinate. And it rises from this y to that y. Okay? And so this is the rise, and this is called the run. So the equation for the slope is rise over run. And you can see, if I put some coordinates on here, let me draw a bigger picture. That is just not big enough. I want an impressive picture, something everybody's gonna want to see. Oh yeah, now we're talking. It looks like the same size, doesn't it? But here is the point x1, y1, and here is the point x2, y2. And this is the run, and this is the rise. So if I want to calculate the rise here, I can just take the difference of the y coordinates. Long one minus the short one gives you what's left over, this space in here. So I can write the rise as y2 minus y1. And the run, just like before, long one minus the short one will give you what's left over. So the long one is going to be x2 minus x1, the short one. And this is our equation for the slope that we're going to use all the time. It's vitally important that these first two numbers are the same, correspond to the same point, and these two numbers correspond to the same point. Doesn't matter which one is which. All that matters is y2 and x2 go to the same point, and y1 and x1 go to the same point. Okay, now right here, let's change color to be pretty. Right here, that's the y-intercept. And we're going to find a lot of intercepts. And whenever you look for the intercept, be it the x-intercept or the y-intercept, you set the other coordinate, there you go, other coordinate to 0. So if I'm looking for the y-intercept, then I'm going to set x equal to 0. If I'm looking for the x-intercept, then I'm going to set y equal to 0, okay? So that's the rule for intercepts. It doesn't matter if we're doing quadratics, polynomials, circles, lines, square. I don't care what it is. If you're looking for a y-intercept, notice on the y-intercept, your x-coordinate is 0. If you're looking for the x-intercept, like here, the y-coordinate is 0 because you're on the x-axis, okay? So that's always going to be true. Okay, so we got the y-intercept, we got the x-intercept, we got the slope. We're all good. Let's do a problem. Should have just deleted it all. Okay, so let's say you got 2 points. You got, oops, can't see that green very well. Haven't figured out how to change these to be a different color yet. And I have not been motivated enough to put in an ounce of effort to figure it out. So whose fault is that? Okay. So I have given f of minus 1 equals 2 and f of 3 equals minus 2. So let's think about what this means. Y equals f of x. So this is my x coordinate, and f of x is always equal to y, so whatever the value of this function is will be my y coordinate. So over here, my x coordinate is minus 1, and what does it say the y coordinate is? Oh, it says it's 2. Okay, so there's 1 point, and over here the x coordinate is 3, and the y coordinate is minus 2. So this is another way of writing an ordered pair by saying f of x equals something, or you could do x comma y, one or the other. Now we want to find the equation of a line. So first thing I'm going to do is look for the slope. Now, as I said earlier, it doesn't really matter which one you make 0.1 and 0.2, as long as you keep their x and y coordinates together. But you can make some smart choices, okay? If I do this one, -2, -2, I'm going to end up with a negative in the numerator. I always try to limit how many negative signs I get. So I always look at the top and I say, which one can I do so that I don't get any negatives? And if I do y2 minus y1, that'll be a 2 minus a -2. I won't get a negative in the numerator. So I'm going to do that. I'm going to make this one 0.2 and this one 0.1. And I do that because I have learned that negative signs are going to be 50% of your errors. And so the more you can reduce the negative signs, the better. In this case, yeah, I don't think you can reduce it. You're out of luck, but at least you tried. Okay, so I'm going to do 2 minus a -2 over -1 minus 3. So 2 minus a -2 is 2 plus 2. -1 minus 3 is -4. So we got 4 over -4. The slope is equal to -1. Okay, we got half of it done. Now I plug it in. Y equals mx plus b. And I'll put in -1. So minus x plus b. Oh, there you go. We're done, right? No, we're not done. Because you got to find the y-intercept. This is only part of the equation. To find the y-intercept, we have to plug in a value that we know is on this line that has x and y coordinates. And we have 2 points. We have one here and we have one here. Either of these 2 points are on the line. I know they are because we used them to come up with the slope. So I know either of these are on the line. So I'm going to pick whichever one looks best. And I am going to pick this one. Because what happens to the -1 when I stick it into x? It's going to become positive. The more negative signs you can get rid of, the better. So I'll do y. So 2 equals minus a -1 plus b. So that it'll be 2 equals 1 plus b. So subtract 1 from both sides. B equals 1. So now I can write the equation. Y equals minus x plus 1. If we wanted to look at a graph of this, the y-intercept is positive 1, so that's right there. And it has a negative slope, which means it's going downhill. A negative 1 means that it's kind of going at a 45 degrees. There you go. So that's what this graph looks like. Let's try to be pseudo-official. There we go. That's much better. So this is our equation. This is what it looks like. Does that make sense? Okay, let's try another. See if I got another example problem. Here we go. F of minus 3 equals 5, and f of 6 equals minus 2. So pause the video here and go ahead and give this a try and see what you can get. And then come back and watch what I do. Okay? Pause. Okay. So now I'm going to rewrite this. I always rewrite these as ordered pairs. X is minus 3, y is 5. And x is 6, y is negative 2. Okay, now my slope. You know, I always write the equation because I find it helps me to think and I'm less likely to make a mistake. You should all do that. Write the equation first. So y2 minus y1, yeah, I'll do this one as 2 and this one as 1 because I'll end up with a positive in the numerator. So 5 minus a negative 2, negative times negative will cancel, over minus 3 minus 6. Oh, we didn't get rid of all the negatives. Half the time you do. Okay, so 5 plus, those become pluses, so that's 7. Minus 3 minus 6, that's minus 9. So we have a slope of negative 7/9. Very inconvenient. So y equals minus 7/9 x plus b. Now we got to plug in. And so, I don't know. I guess I'm going to plug in the top one because the numbers are smaller. So maybe we'll get lucky and something will be convenient. So I'll put in 5 equals minus 7/9 times a negative 3 plus b. So we'll get a cancel. This will go to 1 and this will go to 3. Or you can just multiply it out, 21 over 9, but you're going to have to reduce it. So, and the negatives will cancel. So I'll get 7 over 3 plus b. So 5 minus 7 over 3 equals b. I'll make this get a common denominator. So times 3 over 3. So 15 over 3 minus 7 over 3 would give me 8 over 3. So that's b. So then I end up with y equals minus 7/9 x plus 8/3. Is that right? Not right. What did I make a mistake on? Oh. Did I make a mistake? I'm going to pause for a minute here. I think I made a mistake. Nope, I did it correctly. On my notes, ta-da, I plugged in a positive 3 here, and so the negatives didn't cancel. And so I got a different y-intercept, which was incorrect. Negative signs. They are Newman to Jerry Seinfeld. Newman, negative signs. You always got to be careful with negative signs. Telling you they're going to be half your mistakes. I could see I made a mistake on this example problem in my notes. And so, boo-hoo. So you got to be careful with those. Those are always going to be a problem. Whenever you see a negative sign, you got to watch out for it. If you're thinking of going to grad school and you do the math part of the GRE, man, are there a lot of negative signs, let me tell you. Okay, so now let's do quadratic functions. So a quadratic function is this. Whoops. Y, x. Quadratic function is a parabola, and it's of the form ax squared plus bx plus c. And usually the game is, how do we find these 3 points? This x-intercept, this x-intercept, 4 points. That y-intercept, and the vertex, the bottom point. That's the challenge to these. And if you recall what we talked about before, if I have, well, let's say we have y equals x minus 2 squared plus 4. So that would be, let's see, y equals, our base function is y equals x squared. So that would be like this. So this has a transformation 2 units to the left, to the right, positive direction, 1, 2, and 4 units up, 1, 2, 3, 4. So this would be right there. Okay. I don't know why I showed that as an example, because that's a terrible example. Oh yeah. So when I write it in this form, if I write the function y equals x minus h squared plus k. Notice the point here, 0, 0, has become the point 2, 4, because I shifted 2 in the positive direction and 4 in the positive direction. So I shifted the vertex to there. So if it's written in this form, this is called the vertex form of the quadratic. I can take the coordinates of the vertex right off the picture, right off the graph. This is going to have a vertex at the point HK. So when it's in this form, x minus h squared plus k, we can read the vertex right out of the equation. Easy peasy. And that's the purpose for doing this, okay? If we write it in this form, it's really easy to get the vertex, okay? So now, if we look at the axis of this, let's see, that's how do we want to do that? Okay, so if we take another function, first of all, y equals ax squared plus bx plus c. And in the last problem, our vertex was over here at the point 2, 4, right? Because we had, we had y equals x minus 2 squared plus 4. And if I multiply this out, because it would make me cool, this would be x minus 2 times x minus 2 plus 4. We have to use the FOIL method to multiply this out. That would be first 2, outside 2, inside 2, last 2. And then we have the plus 4 at the end, right? So all of that is this, and then we still have a plus 4, which is inconveniently the same as that one. So if I look at this and add it up, this is x squared minus 4x plus 8. Now, I can read the x coordinate of the vertex right from this equation, because the x The x-coordinate is the same as the line of symmetry. So here's the line of symmetry, where if I fold the curve along that line, it's going to match up with the stuff on the other side. And the way we get the line of symmetry, the way we find the x-coordinate of the vertex, which is this one here, is I do minus b over 2a. That gives us x for the vertex. So let's see, minus b, ax squared plus bx plus c. So b is minus 4 over 2a. A is 1. Minus times minus will become positive. Oh, 2a. 1 times 2, right? A times 2. A is 1, but you still have a 2 there. So we get 4 over 2, which is 2. Holy mackerel, look at that. It matches our x-coordinate. So if I have something like this, this is not in the point form like we had before. Oh, like right here, right? I can see the vertex is at 2, 4, and then I know the x-coordinate really easy because it's in this form. Well, guess what? They're usually going to be in this form. And so we have to do minus b over 2a to find the x-coordinate of the vertex. And that will also tell us the line of symmetry. So the line of symmetry is x equals 2. X equals the x-coordinate is going to be the line of symmetry. Okay? And it's this vertical line right there. So here's the, let's see, do we want to do it that way? Let's see here. Let me look. Hold on. Okay. Yep, we're on the right path. So I have the function y equals minus 3x squared plus 6x minus 5. The rules for finding the x-coordinate of the vertex and the line of symmetry, or sometimes called the axis of the graph. Number 1, get into standard form. That means y equals ax squared plus bx plus c. So you see I'm creating a list of steps, a process, so that every one of these kind of problems looks the same to you. Step 2, identify A, B, and C and write them. People don't do this. They don't want to write. They think, oh, I don't have to do that. I can see blah, 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 blah. Well, people make mistakes because they didn't write them down. I'm telling you, write them down and you won't make a mistake. A equals minus 3. There's a negative sign you could easily miss. B equals 6. C equals minus 5. Okay, step 3. Plug into equation, which is x equals minus b over 2a. You learn in calculus when you're finding critical points why this is the formula, but right now we're just giving it to you because we don't have the calculus to fall back on. There's also a way to find it with completing the square, which is a lot of work to prove that this is true, and you don't want to go through all that work. So I'll just give it to you. I don't like doing that, but sorry. So minus b, b is 6, over 2 times minus 3. So that's 6 over minus 6 minus 1. So the x-coordinate of the vertex is minus 1. Okay, so now we can say we know the x-coordinate of the vertex, the axis of the graph, or the axis of symmetry is x equals -1. So we got a graph, x equals -1, and we know the x coordinate, the vertex is somewhere on here. We don't know where it is, okay? That's all we know. Now, if we want to know the y coordinate, I can just take this and plug it back into my function. To find the y coordinate of vertex, plug x into function. So I'll do that. So up here, y equals -3 times -1 squared plus 6 times -1 minus 5. The minuses will cancel, but this minus won't. -3, -6, -5, that's a lot of negatives. That's -11, -3 is -14. Aha, the vertex is at the point -1, -14. So it's way down here. So it opens up like that. And if I wanted to, I could write this now, instead of standard form, in vertex form. Y equals, let's see, the vertex coordinate is -1, and it was x minus h. Oops, stop. Can I move you? Yeah, there we go. X minus h squared plus k, right? So y equals x minus a -1 would be +1 plus k, so plus a -14 minus 14. So here it is in vertex form. Here it is, the polynomial, the parabola, in standard form, okay? And just for fun, if I plug x equal to 0 into here, what do we get? We'll get -5. This piece here is the y-intercept. It's down here at -5. And we're down here at -1, -14. The next challenge would be find these, which I don't think we're going to do quite yet. Okay? Does this make sense? So follow these steps. Get into standard form. Write down A, B, and C. Write them down. It'll make you cool if you write them down. How's that? There you go. Like me. Ooh. 3, plug them into the equation, x equals -b over 2a. So we plug them in and we find the x coordinate, and that's going to be the axis of the graph, the axis of symmetry. It's right along there. And then we take that x coordinate and plug it back into the function to solve for y. So what we did down here. And then we got the coordinates of the vertex. And then if we wanted to write it in vertex form, it would be fun. We could do that. Or we just leave it in standard form. Okay? So this is the way it works. You want to see more example problems, come to office hours, show up. I'm going to do a bunch of sample problems. I hope I'm not doing them just to myself, because I hear my voice a lot and I'm kind of getting bored with it doing these videos. So I hope somebody else is there that can listen to me. Okay? So come to office hours if you have questions. And thanks. Bye.